So here is a really important concept: sound pressure level. It isn't the same as sound power, and it's not the same as sound intensity either. Pressure level is what we actually measure in the end, because microphones are sensitive to pressure, not intensity. So normally when we're measuring sound, we're measuring it as SPL, sound pressure level. Now we have an intensity that, damn, I should have selected a brush. We have an intensity I, and that is actually related or proportional to the pressure squared. This actually is different at various stages. In the near field, that's not quite right. It's related to particle velocity as well. But on the whole, it's proportional to the pressure squared in the free field. So intense sound pressure level is related to intensity, but it's the pressure squared. So let's have a look at the intensity equation again. We've got 10 log to the base 10 of our intensity being measured over our intensity reference. Now, obviously, that is proportional, is what we're saying, is to 10 log base 10, the pressure being measured squared over the pressure being reference pressure squared. Great thing about logarithms, and if you remember, if we have log base 10 of a number and say it's 10 to the 4, we can move that 4 over here and put it in front, and then it will just be log 10. Well, what do we have to make 10 to, what do we have to do to 10 to get 10? We just raise it by 1, so the answer is 1 times 4, which is 4, which is what we had in the first place. So you can do the same thing here by bringing these squared terms outside of the bracket and then moving it over here, so that the equation then looks like this: 20 log base 10 of the pressure that you're measuring over the reference sound pressure level. So this is the formula for sound pressure level. And one of the things that the effect that it will have is things like when we said when the sound intensity doubled, we got 3 dB. Now we have to multiply that by this 2, so it's actually 6 dB. So we've now got a 2 times a doubling of sound pressure level will give us 6 dB, for example, and 10 times sound intensity was 10 dB. That's now going to be 10 times is equal to 20 decibels. Now, how does that affect us when it comes to this working in a sphere as the sound comes out in a sphere? Well, remember we said that was proportional. The intensity was going to get smeared over a sphere of 4 pi r squared, so it was inversely proportional to the radius that we were moving away from, which gave us r squared, which gave us this 6 dB drop every doubling of distance. If you put it in, if you double the distance, you put in a ratio of 2. If you put that into the 10 log, you get this 6 dB. Now, we know that intensity is related to the pressure here. So this intensity, we could say that that the pressure is related to the square root of the intensity if the intensity is related to the pressure squared. So if we were to replace this with what's happening to the pressure, sound pressure level, it'd be the square root of 1 over r squared, which would give us 1 over r. So sound pressure isn't inverse square law, it's just the inverse law. So for every doubling of distance, we get half the sound pressure level, which is 6 dB. So intensity drops with every doubling by 6 dB. And sound pressure level also drops by 6 dB per doubling of distance, and follows an inverse law rather than the inverse square law. But it all ends up being the same.